to wrap up our factoring lesson that we had recently done, let's go ahead and talk about a term that we had ended with on our previous notes on page 18. So that would be, the key term was solutions. And another word for solutions were zeros. Alright, so as a matter of fact, not zeros, just zero. So our topic is going to actually be zero factor property. Again, nothing new. I just want to go ahead and refresh your memory concerning this Algebra 1 standard. So first and foremost, I'm going to give you a very simple equation. Y is equal to x plus 2 times x plus 5. Now, obviously, this is in factored form. Alright, so previously this in the standard equation was probably y is equal to x squared plus 7x plus 10, and that's what you guys were having a lot of fun doing, was factoring out the standard form equation to factored form. Now, the reason factored form is so helpful for us is for graphing purposes. So if we take, for example, this that's already in factored form, we would break it down into two factors. So I'm going to take my first factor of x plus 2, and I am going to apply the zero factor property. Alright, so 0, literally, we just set each factor equal to 0. And I'm going to do the same thing with the other one here, and that would be x plus 5 is equal to 0. If I wanted to solve for x, I would do the inverse operation and subtract 2 to eliminate it from both sides, leaving me with x is equal to -2. And let's do the same thing over here, but this time my constant is 5, so I'm going positive 5. I'm going to subtract 5 from both sides. It eliminates, leaving me with x is equal to -5. Now, we were talking about positive parabolas and negative parabolas. So remember, if it's down like a frown, oh dear. Oh yeah, I'm going to go there. Have fun with that. That means that your a value is negative. But if it's up like a cup, that looks bright and happy. Oh, yay. Oh, so happy. Your a is positive, and that's your leading coefficient. Now, taking a look here, since my leading coefficient is simply 1, I know that my parabola is facing up. So, I'm going to do a horribly rough sketch here. X-axis, y-axis. And here I have a solution, a 0, a root, an x-intercept of -1, 2. Then I have another over here at 3, 4, 5. Like I said, this is just a rough sketch. This tells me, oh goodness, I totally missed the mark there. That eraser is just not good. Not as bad as those other erasers we got on those free pencils, but there we go. So what this is telling me is that I have a parabola that's facing up that crosses my x-axis at -2 and at -5. So if I were to ask for the solutions of this, parabola, I would say the solutions are going to be in ascending order, -2, comma, oh, oops, put that in the wrong one. In ascending order, there we go. -5, comma, -2. And of course the pen is running out. Great. There we go. Nothing wants to be nice for me today. Make this work. There we go. Okay, so those are my solutions. And one other thing I'm going to write here. Just so we have it written down somewhere. All right, and that is the whole purpose of getting these these quadratic equations factored, is to actually solve for the solutions, or, well, the x-intercepts. So let's go ahead and try out another one. Let's try, you know what? Since we already know how to factor, and you guys had a lot of fun doing that, we'll go ahead and start with a standard form. Y is equal to x squared minus 7x plus 10. And this is very similar to the previous standard form equation that we had, just this time my b is negative. So if I set it up into my puzzle pattern like we've been doing the past 2 days, I would take my 10, put it on top, my -7, put it on bottom, and we would get the factors of 10, starting with 1 times 10, 2 times 5, 3, 4, 5, that's it, all right? And obviously, if I subtract these two, there we go, -2, -5. So my factored form would be x minus 2 times x minus 5. Now, all I've done is factored. I want to know what are the solutions to this equation. Once it's factored, now I can use my zero factor property and set both of these equal to 0. Alright, so let's begin. We're going to use the inverse operation. Ta-da! And over here, let's do the inverse operation. It's subtraction again, so that would mean I would add 5 to eliminate it. So x is equal to +5. So again, I have a invisible 1 there, or an implicit 1, so that would mean I'm still facing up. So I'm going to draw x, y axis, and this time here we're going to go to +1, 2, 3, 4, 5, notice there's not very much scale on this. All I know is that my parabola is going to be facing up, and it has 2x intercepts, one that goes through positive 2 and the other one that goes through positive 5. So for my final answer, I would say, let's use another term other than solutions. How about the word that we have up on top? We would say the zeros will be, and again, whenever you're listing out solutions, roots, or zeros, they will be using braces. So we're going to put that again in ascending order, so that means least to greatest. And that would be my answer. Beautifully done. Okay, let's go ahead and move on to our next example. Like I said, this one's kind of fast because, well, we've already done it before. So, let's put number 2, number 1, and scooch this up for number 3. And that would be y is equal to x squared plus 3x minus 10. Okay, so some of you guys didn't want to write out the boxes, and I'm fine with that, absolutely fine, because really your work is kind of redundant here. So I'm going to go ahead and circle my C value, box my B value, and find the factors of the absolute value of 10, just like we said in our previous notes. So 1 times 10, 2 times, we still have the same numbers. Now, the thing is, this time, we need to try and get a positive 3. Obviously, 1 and 10 is not going to get me there. But, usually I would say that would be 7. But remember, you can add or subtract these pairs of numbers to get that B value. And I know if I have a positive 5 and a negative 2 that are combined, that would definitely get me that positive 3. So, I have my two values. Let's write this in factored form. That would be x minus 2 and x plus 5. And now let's apply zero factor property. Setting each of these binomials inside of the parentheses equal to 0. And my second binomial equal to 0. Okay, so let's start with the first one. Our inverse operation in this case, since it says x minus 2, well, that would be the opposite, plus 2. It eliminates that, giving me x is equal to positive 2. Alright, let's go ahead and do the inverse operation on this positive 5, which would be, of course, subtract the 5, gives me a 0. So therefore, x is equal to negative 5. That would leave me in a situation that, again, I'm nice and I'm keeping you with a is equal to 1, so I have a happy positive parabola. But this time, I'm kind of like all over the place, so put it maybe like this. With my x-axis here, my y-axis there, that would be positive 1, 2, negative 1, 2, 3, 4, 5. Why not? Give me some wiggle room there. Ooh, this one's going to look really funky, so you know what? I already know it's going to be wide. I'm going to bring that down just a bit. We'll have space to write on that other side anyway. So I have x is equal, so x-axis, to a positive 1, 2, right there. And x is equal to a negative 5, that's negative 1, negative 2, negative 3, negative 4, negative 5. I have a positive parabola, so let's see, that's, Okay, I was just trying to find my approximate axis of symmetry. So why not? Let's have it come over here. Because remember, smack dab in the middle of these 2 points, I will find the axis of symmetry. So I gave it a little approximation there. There we go. Okay, let's go ahead and label this one page 19, and then flip it on over. We have one last problem to go over, right? I think. I'm pretty sure. Yeah, here we go. Let's see. Actually, I'll do one with you, and then what I'll have you do is one on your own, then I'll check whenever you guys return. Yeah, why not? So, how about y is equal, actually I haven't had you guys do this one before, so you know what, we'll end with this one, and I'll give it to you in factored form. There we go, that would be 3x plus 2 times x plus 5. Now, you'll notice that we do have a value larger than 1 here, or that's not equal to 1, to be more specific. So, we'll go ahead and double check by doing double distribution at the end to figure out what our a is, so we know if it's going to be facing up or down, okay? But since it's in factored form, let's go ahead and solve for our x-intercepts. So we would write 3x plus 2 is equal to 0, and x plus 5 is equal to 0. Interesting. So let me just make sure. Okay. This is not going to be treated any differently. Let's go ahead and use our inverse operation. You know what, we'll do the easy one first. So to get x alone, x is currently being summed up with 5, so we're going to subtract the 5 from it, eliminating that and giving me x is equal to negative 5. I've noticed this is where you guys struggle a bit more. So just like we removed our constant first, and I believe it's page 11 that you can refer to as well. No, 10, 11, gosh. Our substitution notes. It'll say there that we should remove our constant first. So my constant is 2, and it's being added on there, so I'm going to use the inverse operation and subtract it out, leaving me with 3x is equal to negative 2. Do not forget that 3 and x, even though 3 is just the coefficient, it's being multiplied by x. So since my operation is multiplication, it's inverse division. And remember, whatever you do to one side, do to the other. 3 divided by 3, please don't say the C word, reduces to 1. Leaving me with x is equal to negative 2/3. Yeah, it's ugly. I understand this. But it's a number. It's approximately negative 0.6666666 until infinity. So the question is, if I wanted to write this down, my answer, and I would write down, so we've already used solutions, zeros, and then there was another term we said was roots. I'm going to go ahead and write over here, roots. We would again use the brace, and only the x values that we solve for, we would look for the smallest one here, which with negatives is kind of the opposite. So that would be negative 5, comma, there we go, negative 2/3. Okay, now the thing is, anytime I ask for a root, a solution, or a 0, I only want the x value. But this is very important for testing purposes. If you are ever asked what is the x-intercept, this is very specific. An x-intercept is located on a Cartesian plane. I expect to see a coordinate, an x and a y value. And you recall that any x-intercept, well, it's going to be some number, comma, gosh, my commas are coming out awful, 0 as the y value. So I would write down, well, negative 5, comma 0, and negative 2/3, comma 0. Big difference between these two, okay? And you will be seeing questions like that on your exam. I think I'm going to still leave you with a similar problem, and that one will be, okay, so that one was number 4. I'll leave you with one problem to do on your own, number 5. Please find the solutions, so I'd like you to just write the x values. For the factored form, y is equal to x plus 2 times 3x plus 5. And I'm going to give you a grade for this one problem. Apply zero factor property, then tell me that the solutions are, and then finish it off, okay? All right, I'll see you guys next time in class.